Thank you. Good afternoon. My name is Jānis Dzērve, and today I'm going to talk about drones and security of the drones in terms of data security, although the drones themselves present an obvious physical security as well, security threat. I am now representing a company called UGCS, which develops software for the drones, and I have a pretty good experience of all the communication protocols which are involved in this drone business. And when I'm saying drone, I mean vehicles like these on the table. We are not talking here about military-grade Predator-type drones here. So my personal belief is that in some time there will be a sky full of these vehicles, just like cars now, and nobody predicted that there will be such many cars today 100 years ago. So I predict a similar future for unmanned aerial vehicles, and this is just the beginning. And to connect it to with the conference theme, so there is a pretty lot of security involved, data security involved in the drones as well. I have a 15-year experience of the program in the programming, computer programming, and low-level stuff, and I have a master's degree in computer science, and this is also my hobby as well. So I have a luxury having a job the same as a hobby. So let's begin and see what we'll have here. So for to first we'll see what the drone itself, what does it mean. So I'll start my clock so I don't run out of time. So there are various components in the drone which can be vulnerable to various security attacks. So the obvious ones are the control channel. So this is the channel which you are using to control the drone, and obviously it is a wireless, so radio channel. That is the channel which is used for user commands from the ground to tell the drone where to fly. Telemetry channel is the backwards channel, so it tells where the drone is and what does it do. And then there are various sensors on the drone which provide the location awareness of the drone itself. So there are a bunch of them. In modern drones, I can easily name at least 10 different sensors like altitude, GPS, barometer, accelerometer, and gyroscopes, and so on. And all of those are basically attack surfaces. So when we talk about this, then we need to understand that the drone, typically in data security, in IT security, we talk about the security of the data, which is also present in the drones, but the drone itself presents also a physical threat. So you can attacker can mangle with the control channels of the drone and land it or crash land in inappropriate places. And we already know that it has been the case already, and they had pretty big publicity as well. So we will go deeper into these issues, and I'll try to explain what is this thing about. So what we can do, what's the current state of the what's the current situation with data security on the drones? So for consumer level drones, ease of use is the king. So if user wants to, if producer wants his drone to be purchased, user doesn't want to do anything, just plug it in and fly. And as you know, data security is about the balance between ease of use and security, basically. And in these kinds of vehicles, this ease of use prevails big. And on the drone, there is an actual computer running, because that's why they became so mainstream, and becoming so mainstream just recently, not just 10 years ago, 15 years ago. There was no such thing as this, for example, you can buy in each store now. That is because it needs quite a lot of computing power to actually stay airborne, and all those drones are actual computers. So that basically means if they are bigger than even the smaller one, the black one has a Linux running on it, so it's a full-fledged operating system, and the white one too, which includes the file system, the network stack, and everything. So you have an FTP servers, web servers running on the drones and stuff like that. So all the stuff we are talking here in this conference also applies to these things. Plus, in this case, you can take control of the drone itself, like where to go, what to do. And of course, you can, or attacker can sniff or steal the information, what drone is seeing, or what data it's gathering. So there is some ideas what we can do to make this easier, to make this more secure. And for example, this thing, when you turn it on, it creates a wireless access point without a password, without encryption. So basically, once you turn it on, everybody can see it and log in, and there's no security whatsoever in terms of passwords, users, or anything. Just when you telnet into it, you get root access to the Linux on board, which is basically you get everything. So this is a pretty old model, like 5 years old. But also the newer ones are, from the security point of view, are the same. And there are also already, you can download on the internet rootkits for this thing, so you can either hijack your neighbor's drone or use your drone to hijack neighbor's Wi-Fi and stuff like that. So basically all you can do with the Linux, you can do with the drone, so you have a flying Linux. What can be better than that? This drone also uses Wi-Fi, but at least it's encrypted, although the encryption password is on your phone, and it needs to be the same on all the devices which is connecting to it, so it's also pretty non-secure, I would say. There are other drones which are not using the Wi-Fi. So the Wi-Fi is used basically because it's so common and because it's so understandable, accessible from everywhere. So basically you control these drones with your with your phone or laptop or tablet. So to secure that thing would be easiest way would be to do a secure Wi-Fi at least, and use some more serious encryption than it is used now. But that would involve configuring your device which is connecting to the drone, and that also then that's a time and user don't want to do that. They just fly and film whatever they want. Another thing about the securing the system on board the drone is doing some encryption on the file system, or at least encrypting the channels, authenticating the users and encrypting the data which is going back and forth to the drone. Of course, these vehicles have not so powerful computers on them, so encryption can take some power from the flying controller, but today's solutions for that make this argument irrelevant. So encryption currently does not slow down in general. It's not a big deal in terms of computing power required. This is more about administration of keys and stuff like that. So, and to go into deeper specifics here, I can tell about two cases which I have been part of and know. Well, it's kind of white hacking, and in part as part of my job was to understand all these communication things drones are using. So there are two case studies, and one of those I already mentioned. So started to mention is that they are using a standard Wi-Fi connection with no encryption, no authentication, and so the drone is fully exposed, and that's the black one on the table. On the second one is using a dedicated radio channel, which is not a Wi-Fi, but it's the same frequency, because that's the frequency which you can use freely. So so there's no need for no restrictions on the frequency use apart from transmission power. It does use encrypted protocol, but there is no authentication. So once you get the key, you can connect to the drone, to any drone basically, because the key is hard-coded into the drone itself, and that means that basically, if the key is somewhere stored when everybody can look at it, there is no point of encryption at all. So it's kind of harder to get into the second drone. Well, not this one, but there is another vendor, and so there is no point having to have an encryption if you can get the key. It kind of slows it down, but once it's broken, it's broken for everybody. And so we can wish that in this area, in this industry, we can it can do much better than that. How exactly? So my theme was called how to hack a drone. So I think that the answer is currently, at least, and it refers to the consumer grade drones. It's easy and trivial, basically. And I think that from what I told, it's you'll agree with me. There are more. There is one more thing I wanted to tell is that my work involves like I'm working with different vendors of the drones, so we buy them, we test them, and we make software which is able to connect to all of various possible autopilots and vehicles. So and none of them is actually secure from what IT professional would expect to be. And that's a big problem, and then we could improve in that sense very much. So somehow in perspective of time, this is about the time where internet was like 40 years ago, when there was an FTP protocol which you can transfer files between two servers. Logging into each other, so that's basically not allowed in current situation. This is a very bad practice. So no encryption, nothing. So these drones, from the security point of view, live like 40 years ago, and we need to do something about that. Definitely, there is one example where this can be very critical. So we have a scenario when a client wants to use a drone for physical intruder detection. So you have an industry or a pipeline which has sensors for intrusion, some fences or cameras along the line or along the fence. But when the sensor goes off, you don't know what exactly happened. So they know where the sensor was, but if that's a 100-kilometer pipeline, you need to send a patrol there. So what they do is first send drone there to see what's going on. And while the patrol is on the way, the drone can at least give you visual control. So, for example, in these scenarios, it's very important that the drone itself is pretty secure. One important point which I did not touch much, but I know there is a discussion, a lot of discussion about that, is also that these drones heavily depend on external infrastructure, and the main part of it is GPS. The drone itself is blind, and mostly, I don't know actually about drones which are able to fly without GPS. So, for example, the attacker can just what was the word? Interfere with the GPS frequency, and drone will go nuts, and typically it will land. It will just land itself to avoid some crash landing and stuff, or try to hover. But the sensors on the drone can hold it in horizontal flight, but they cannot work against the wind. So wind will blow them somewhere or the whatever. So if there is no GPS, drone is basically useless in our case. And there are even scenarios when a sophisticated attack is not just smash the GPS signal, but actually spoof it to some extent, that so the drone is thinking that it's using a legitimate GPS, but actually it's spoofed GPS and it makes it land normally somewhere where the attacker wants. So that's a very possible scenario. Of course, it involves quite a lot of hardware and technology, but currently it's already possible. So that again, one more thing. The problem with drones, why they are not flying around already in the air, technologically it's already possible. So we have these which are capable, like, okay, this drone can fly 20 minutes, but there are drones which can fly 100 minutes, like an hour or so. The problem why so the gain they are giving to society and to us, I think, is very big. And the problem why they are not there is that it's political issue. So we need to put our act together and understand. So if, for example, the question when the drone goes down and hits something, who is liable, either the vendor of the drone or the owner, and how do we find one or the other? So all those things are currently being discussed heavily in US and EU. And that basically is my presentation, what I wanted to talk about. I apologize, I am not very frequent guest in such conferences, so my talk may be not that fluent. Sorry for that, but I want to, I'll open question answer session if you want, if there are any questions.
Okay, thank you for the presentation. I'm sure there are questions. If I may start this time, you understand that your presentation is mainly on the technical aspects of drone security, but you did touch policy perspective in your last sentence of the presentation. So if you can comment, I don't expect you to do that, but if you can comment on the policy implications of these drones versus military drones. So you said, well, we need to have some liability for these drones, either the vendor or the operator is responsible. So do you know anything about the military drones regarding that? Is it already resolved in military area? So which area is going faster policy-wise, this or the other one?
Well, I'm civilian, so I don't know actually anything about military drones. But I do know that in Latvia, they just passed a law, I think a few days back, when military is allowed to take the drone down if it flies over a military base.
Is it okay to shoot the drone if it flies over my
No.
backyard? Why not?
Actually, there was an interesting case in the US when somebody shot the drone with a shotgun, and it turned out it was neighbor's drone, and he sued him, and he sued back, and I think the trial is still going on. But the main issue, what they are, the case was about a reasonable expectancy of privacy, right? And under this clause, this case goes, so was that your drone, like the drone flying on my land, was it penetrating my expectancy of the privacy? So that's the question. But that's an American law, and I don't know that about anything like that in Latvia.
So policy is being formed as we speak. So do we have some questions here?
Actually, I have two, but very quick. First, why these drones are not using some already in place standards? It's common for Linux and Windows and everything else in IT to have some standards, and now these standards are pretty secure. Why just don't use them? And the second question is, what about you have spoken about Wi-Fi, but what about GSM networking? Would be that this would give drones much wider range and much wider data capabilities.
GSM networking is pretty much as IP networking in this sense. So there are already drones which have SIM cards on them, so you can control via GSM network via actually internet. So native GSM, I don't know, but it's IP over GSM, IP over mobile. So about the standards, yes, the problem is that there are no standards and no even de facto standards or agreed upon like best practices in the radio link communications. I think that is because this industry is pretty young, and military has that. Military has been doing this for 50 years already. And why this was not available for civilian users? Because of the cost. And the cost went down just recently, and now there are full stores of these drones. So every vendor who is doing this tries its own approach. And we are actually one of our businesses actually make all these drones to work together. Like I would call that the standard, yes. But the protocols they are using there's quite a myriad of whatever the bytes they are sending, and the standards they are using are very, very open in the sense that not encrypted, but also not defined well. So.
Okay, we've run out of time, unfortunately, so thank you a lot. Can I have a round of applause again for Jānis Dzērve for his presentation here? And, of course, a gift from Data Security Solutions to you.
Thank you.